start with classes. What is a class? It's a collection of processes and threads that has a set of resource limits. And that's how Workload Manager assigns processes. So class assignment is used to group processes and threads. Shares and limits are used to control them. The superclass or subclass is just a group of resources, that's it. There are 5 predefined superclasses, and you can add another 27 for a total of 32. And then for every superclass, you can have 12 children. There's 2 predefined and 10 user-defined, and we'll go into what those are. And every class name can have a maximum of 16 characters. You can't have special characters in the name. They're only upper and lowercase characters. And you have to be careful, like don't accidentally use the name of a command or anything like that, because it should work, but it's always wise not to do that. So typically the rule I use is that I have my classes they always start with a capital letter. Superclass names must be unique, so you can't have like 2 superclasses called SSHD. And subclass names are unique within their superclass. So I could have an SSHD.Jackie and a Monet.Jackie, but I can't have 2 superclasses with that name. What are the predefined superclasses? We have default, system, shared, unclassified, and unmanaged. And I'm not going to go into all the rules around them, but these are the ones that you will get by default. You will see some of them in the limits file and the rules file. These are not ones that you get rid of. Be aware that if you are going to apply limits, there's some rules around which ones you can apply limits to. As an example, you cannot put a hard limit on memory for the system superclass, and the reason they don't let you do that is because you can create deadlock situations so that processes end up waiting on each other, which is never a particularly good situation. You don't want to have a process swapped out that's holding the memory that another kernel process needs. Some of these control memory, as you can see. Under system, we have all the memory map pages belonging to system memory segments go here. Some of them control CPU and memory. If you look at unclassified, this is where stuff that WLM doesn't know what to do with go. But as an example, if I have a closed file, the pages that are in memory for that closed file are going to show up classified. Then when the process opens the file, those pages will be reclassified to whatever Workload Manager class the process is actually running in. Then under each superclass, you'll find some subclasses, and the predefined ones are default, which is everything else, and shared, which is any shared memory pages. So that's pretty simple, and then you can define your own. In terms of classification, files get set up in the /et/WLM directory. You'll create a subdirectory for the schema. So I called mine prod95. The default is standard, and what you'll see is that there is a link from standard to current. If I was to start up my prod95, the link would be moved such that prod95 would be linked to current. That's how it keeps track of what the current one is. Within the subdirectory we just created, if we want to create subclasses, we create a directory with the name of the superclass, and then we put the files in there for the subclasses. And I'm going to show you all this, so don't worry about trying to memorize all this. If you want to have schemas, and this is where Workload Manager can be very cool, if you want to have schemas that automatically switch, for instance, let's say you run one way from 9 to 5, but then you want to prioritize something else from 5 till midnight, and so on, you can set up cron jobs to automatically switch schemas just by running the WLM control command. A couple of other things to note with classification, if you find that things are ending up in the wrong place. Workload Manager reads the rules from the top to the bottom, and it assigns a process to the very first matching rule. It does not keep reading to figure out if there is a better rule for this process, if there's something that's more granular. So what you have to make sure of is that your more granular rules are at the top, and you work your way down to the more global ones. I already talked a little about how processes are assigned, but I'm going to show you with the rules what you can do. A thread gets assigned to a class based on processor owner ID or process group ID, an executable name using a full path. You can use a corn shell pattern, like you can see here I've got /usr/oraclebin db star. I haven't had a lot of luck with those, to be honest, so I tend to put the full path to the command, but you may have better luck than me. And then they have these application tags, which I have never seen used. I have seen types used where you can say, I want everything that is 32-bit to go into this class, or everything that's got using PLOCK to pin memory to go into this class, and so on. And you can combine them. So you can say 64-bit, PLOCK plus 6, which says any fixed priority process that is using PLOCK and that is 64-bit. What you can't do is combine 32 and 64-bit. So you can get really fancy with this. For the most part, you will use the first three: process owner, process group, and the executable name. So in terms of attributes, the attributes that a class can have, obviously it has to have a name, which is up to 16 characters. In terms of tiers, we've already talked about those. You can have 0 through 9. There's also something called inheritance, and basically that is if a parent process is running, if it spawns a child, does the child inherit the same class assignment? And so typically we put inheritance equals yes. You can also have admin users and auth users, so that you can delegate the right to manage and administer classes. So for instance, if you don't do that, the only person that can change a process manually using WLM assign is root. But if you want a particular user ID to be able to do that, you can delegate that right using auth user. You can also limit the set of resources in terms of CPU, and you'll see some of that. And then you can also specify whether or not memory segments remain local to the class they're initially assigned to. So if I start to share my memory segments out, how does that work? Now, in the red book, the one I was talking about from 2001, I've given you the name of it and the page where there's a lot more detail on all of this there. These are just some of the things that I wanted you to be aware of. And this particular slide here is talking about inheritance for classes. So if you have inheritance equals yes at both the superclass and the subclass, then the child will always remain in the same subclass when it gets executed. And then there's the various flavors here of if you don't have it at the superclass but you do have it at the subclass and so on. I'm not going to go into this in detail, but just be aware that when you're coding inheritance that you need to understand the different flavors of it. I mentioned tiers earlier. As I said, you can have up to 10, and they're basically used to prioritize classes relative to others. So, for instance, if the scheduler goes to run and it's trying to figure out which thread to run, it will always pick a process in tier 0 over a process in tier 1. If you have a tier, it will apply to both the superclass and the subclass, unless you specify a tier in the superclass or the subclass that is different. So if you want to add them, you basically go into the superclass classes file and you change it to add a tier. So if you look at this one here, you'll see that I've got these different classes, Group A and Group B and systools. And under sysbatch, I added tier 1. It will go into tier 1 because it's low priority. Everybody else will be tier 0. And I've got to note that inheritance equals yes means that any process started in the class stays there. So you can see it's pretty easy to code a tier. When we look at shares, they're a relative entitlement to the available resources. And basically, you can use it to impose limits. I'm going to show you a file rather than talk about this slide a lot. So here, in the shares file, I only have 2 shares coded. I have Group A and Group B, which are my classes, and I'm saying that for Group A, it gets 3 CPU shares and 3 memory, and Group B gets 2 CPU and 2 memory. What that means is there's a total of 5 shares. Anytime that resources are being fought for, Group A will get 3 out of 5, or 60% of the CPU, and Group B will get 2 out of 5, or 40%. If resources aren't constrained, it's not an issue. And if, by the way, there is nothing running in Group B, then Group A really gets 100% if it needs it. And that's assuming nothing else is running. This is a very, very simple case. You can also put shares file for Group A subclass. I can also add CPU and memory shares, etc. You don't have to code a shares file. As I said, I always leave mine empty. The other thing is if you only have one thing in a tier, so for instance, in the slide back here we have sysbatch in tier 1, but it's the only thing in there, then since that's the case, we don't need to bother with coding any shares for that because it's the only thing in the class, so there's nothing to share with. Limits is where you get the real power. And limits are used to define minimum, soft maximum, and hard maximum for the resources. The minimum is what has to be available when requested, and typically you'll see, I think it's a system class, always has 1% for CPU. So there's some rules around minimums. As an example, if I add up the minimums within my tier for a superclass, they can't exceed 100%. I can't say that every class has to have 50% when I've got 3 classes because there's only 100% for them to take those minimums from. So minimums can't exceed 100%. The same with the subclasses. For a subclass, I can't exceed 100% for that superclass. So if my superclass minimum is 20%, my subclass minimums can total 100% of that 20. The maximum is the percentage that can be made available when there's contention with other classes. So if I'm starting to fight with other people, the maximum is basically going to be imposed. And if there's no contention, then I can exceed my soft maximum. So that soft maximum has to be less than or equal to the hard maximum, and that hard maximum can never be exceeded. So if I have a soft maximum of 60 and a hard maximum of 70, if no one else is fighting with me for resources, I can use 70%. But if people are fighting with me for resources, then my soft maximum will be implemented. And as I said, you can't set hard maximums on the system class. And by the way, I've got a note down the bottom. There's a /etc/secure/limits file, which is a system-wide limit file for memory and so on. If the maximum limit that I specify in this limits file exceeds the etc secure limits, the system-wide limit will overrule it, and so processes will be killed if they reach the system-wide limit, regardless of what WLM has configured. So you never get to exceed the hard-coded system-wide limits. On most database systems, we tend to make those unlimited, but it's just something to watch out for. So here's a sample limit file. My default group, I have limits set for CPU from 0 to 10% and a maximum of 100%. For memory, 0 to 10 and 100. For system tools, I don't actually have a hard limit on it. And for my system, I've said 5% CPU, 5% memory. Soft limit of 50, maximum limit of 100. So you can get pretty fancy with this. You just need to apply some common sense so that you don't put yourself in a situation. So for instance here, under system tools, once it starts using more than 5% memory, if there's contention for memory, I will start stealing pages from system tools rather than give it more. So you just have to be a little careful. I think 5% is too low. I just wanted to show you an extreme example. And basically what that minimum says is, if I'm using my minimum, you don't get to steal my pages. And then you can do the same thing for subclasses. Here's a more likely example that you would see. Here I've got my system set to 5 to 100. There's no limit on the system. I've got my SAS, which is a memory hog, and my Stata, which is a memory hog, set to 60% soft limit and 60% hard limit. So if I was running in active mode, any job that's classified as SAS or Stata would not be able to use more than 60% of the memory. And I didn't bother defining CPU limits for SAS and Stata.